Bismillahirrahmanirrahim. Alhamdulillah wa salatu wa salam ala Rasulullah Muhammad bin Abdullah wa ala alihi wa sahbihi wa mawala. Good evening, my listeners, my viewers, and my subscribers. Welcome to this platform as Source Academic Online Class. And today I will be treating a review question. What are the secret questions that jamb do ask? As far as jamb is concerned, what are the things that they do ask? Basically under organic question, organic topic. Organic chemistry. What are the likely questions? So on today's platform, I will be showing you on what are the likely questions on alkane, alkenes, and alkyne. So I'll be showing you something on that. Now let's quickly pick alkane. As alkane is concerned, we have done the nomenclature of alkane. How to name alkane. Please, if you don't know how to name it, they do ask very well. If you don't know how to name it, go and check more. At Sub Academic Online Class, you will see how to name a proper naming of alkane. Within this period of time, you can name alkane very well and you will score a very good what? Very good score. Go and know how to name that. We have treated that. Today, what we are going to be dealing with, what are the review questions that jamb do ask as far as this subtopic is concerned under organic chemistry. Now note that, firstly, understand what we mean by alkane. You have to digest that. What is alkane? This is not about cramming. Jamb, they don't expect you to cram. All they want is just your digestion. How did you comprehend what you have been taught during your SSCE what? SSCE certificate. How did you understand it very well? And now note that in this alkane, the definition of alkane, note that it is a what? Is a single bonded molecule. So if jamb will ask you now, dash amidst the organic compound happens to be a single bonded molecule. What organic compound? What organic compound happens to be a what? A single bonded molecule. A single bonded molecule, as far as organic chemistry is concerned, is alkane. Alkane happens to be a what? A single bonded what? Molecule. So let's define what is an alkane. An alkane, this belongs to the group of saturated hydrocarbon. It belongs to the group of saturated hydrocarbon. When something is saturated, meaning you notice is CH4. CH4 is what? Methane. Methane. Some call it methane. Anyhow you want to call it. We are not in English class. Methane. Know that for a single carbon to be a carbon, there must be 4 hydrogen attached to it. 4 hydrogen attached to it. This is the structural formula for methane, while this is the molecular formula for methane. Carbon, 1 carbon, there must be attachment of how many hydrogen? 1, 2, 3, 4. So if there is attachment of 4 hydrogen to 1 carbon, this compound has been saturated. If I add another hydrogen, it becomes unsaturated. So for 1 carbon to be a carbon, there must be how many hydrogen attached to it? 4 hydrogen attached to it. The same thing applicable, let's pick what? Ethane. Ethane is C2H what? A6. C. Now, how many hydrogen? 6. Let's print them. 1, 2, 3, 4, 5, 6. Hydrogen. Now check. This is 1 carbon. Let's say how many hydrogen? 1, 2, 3, 4. This middle one is also hydrogen, but it is hidden hydrogen. Let's count this one to 1, 2, 3, 4. Now we call this compound, we call it saturated hydrocarbon. So in your definition, when you are trying to understand what we mean by alkane, know that they are single bonded molecule. They are single bonded organic molecule. Are you jotting it down? They are single bonded organic molecule. That's number 1 key point. Why do we call them single? See, what is the bond that joins the carbon and carbon together? How many bond is there? 1 bond. When I mean 1 bond, I mean this. It is not double bond like this. So we call it, that's why they define alkane as a single bonded organic molecule, single bond. And it is saturated hydrocarbon. Why? Because for 1 carbon to be carbon, there must be 4 hydrogen attached to it. More than 4, it is not saturated. So that's why they classify this into what? A saturated hydrocarbon. Have you noted that? Single bonded molecule, saturated hydrocarbon. And it has a general formula. These are the key words. Sorry that I'm rushing. We should make the target. It has a general formula CnH2n plus 2. Jamb do ask. CnH2n plus what? Plus 2. Cn Now we have done, it is a single bonded molecule. I think you have understand that. So whatever structure they draw, and you see a single bond binding carbon to carbon or carbon to hydrogen, you know that that particular organic compound, it is alkane. It is what? It is alkane. Now the second thing, we said it is a saturated hydrocarbon. You have known that. One carbon from it, I've drew ethane. One carbon should have 4 hydrogen atoms attached to them. More than 4, we don't call it saturated. So A and E, know that it is saturated. Then might now ask you, they will list some options. They will now say, I miss this option. Which one happens to be a saturated hydrocarbon? They can put alkane, they can put alkenes, they can put what? Alkyne. Now what will be your answer now? It is alkane. Note that only alkane happens to be a saturated what? Hydrocarbon. Saturated hydrocarbon. Now this one, it is not saturated. Unsaturated. This one is also what? Unsaturated. When we get to that, I will let you know the reason why it is. But know that this is what? A saturated hydrocarbon. Have you picking that? Single bonded molecule. Saturated hydrocarbon. These are what jamb need. Just understand the key words there. Now the third thing that I will let you to know is that it has a general formula. That is a common question that jamb do us under this A and E. It has a general formula. Please cram that. Put it offhand. It has a general formula CnH2n plus 2. It has a general formula CnH2n plus 2. They do that. They will just list it out. Which of these, the jamb we are asking now, which of these organic alkane as an organic compound has what general formulas? It has what general formula? They will now put A, they will make it A, this, B, they will make it CnH2n, C, they will make it CnH2n minus 2, and many more. They can pick D, CnH2n plus 1. Then E, they can put CnH2n plus 1 OH. Note that. Don't let all this come to your mind. This is the correct option for alkane. It is a common question that jamb do ask. That alkane has a general formula what? They will not list all this option. Know that the correct answer is this. CnH2n plus 2. What is the reason why for we picking this? You know, the family of alkane started from what? Methane, which is CH4. Now let's use this general formula to get this thing. That's what we want to get this molecular formula. So that means carbon number 1. If it is ethane, carbon number 2. What follow? Propane, carbon number 3. What follow? Butane, carbon number 4. Butagon from mathematics. What follow? Pentane, pentagon from mathematics. But in chemistry we call it pentane. C5. Hexane, hexagon. What follow? Heptane, heptagon. What follow? Nonane, nonagon. I'm relating it with mathematics class. So when you get this, know now all these things. This is 1. Ethane is 2. So let's use this to derive this. This is carbon number 1. N, you make it 1. Whenever I'm saying N, I'll be putting 1 there. Let's put 1 there. C1 H2 times, we still have N here. Put 1 there. Plus, for we to get this. Plus what? Plus 2. Now let's balance. 1. 2 times 2. 2 times 1 will give us what? 2 plus 2 here give us 4. But know that you don't have to put this one there. As a mathematics student, as a science student, you don't need to signify it. So since we have C1, that means we are talking about we have only one C, which will be CH4. See, now we have gotten this. That's why this will be the general formula for what? For determining the molecular formula for ANE alkane. If you want to still do for ethane, ethane will be number 2. N will be 2 now. Whenever I'm seeing N, what will I be putting? It is C2H6. So when you use this formula, without even cramming, you use this formula to get this. Should we input that? What follows? This is N. Whenever I'm seeing N, I will be putting 2. H, 2 times what now? 2 plus 2. What would that be? It will be C2H, 2 times 2, 4 plus 2, 6. This is ethane. Then you can do that of propane. What follows? Butane, hexane, pentane, and many more. So it has a general ANE alkane has a general formula CnH2n plus 2, and that is a common question that damn do ask. Please don't go for this. Please cram this offhand. Are we together? Now, another thing under ANE, we are still under ANE. It has a bond angle. It has a bond angle. They do ask that. Well, alkane has what bond angle? When we say bond angle, when I draw this thing like this, hydrogen, 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 hydrogen. This is what structural formula for methane. If I ask you what is the bond angle, what is the bond that is in between this and this, we call it bond angle. What angle do we form here? That's what we call bond angle in chemistry. Now, what is the angle? Please count that as well. It is 109.5. This is the bond angle. So they will now say, alkane has what bond angle? Is it 109, 109.5, 120 degree? What follow? 180 degree. They will list the option. Please don't go for 120. Don't go for 1. So they will now list all this. So the question will come like this: what is the bond angle of alkane? Or alkane has what bond angle? You know, it's as a result of the time I will be bringing the question. But if you have the JAMB series, go and check all what I'm saying. You'll be meeting them there. I'm just doing the summary and the review of what they might likely ask you. So please try and know that. What is the bond angle? I told you that this and this is what we know as bond angle. So you know this structure now is methane. You know how it is methane. How many bonds that we have? It is a single bonded molecule. I've said that. It is saturated hydrocarbon, meaning 1, 2, 3, 4. Hydrogen is well okay. It doesn't need anything. Now what follow? The bond angle. It is 109.5, which is this. So JAMB we now put this one as the bond angle. We put this one, we put this one, we put this one. This is for another thing. This one is also for another thing. This one is from another something. So please, this is the correct answer there. Are we together? Now another thing that JAMB might still ask, that what organic compound has a tetrahedral in shape? What is the organic compound that has, or that is tetrahedral in shape? That is what? This is tetrahedral. In what? In shape. Know that it is Alkane. Alkane is still the same thing. So it is the shape that alkane do bring. It is tetrahedral in shape. It has a four side. What do we mean by that? Now let me use this to do that. So if I happens to do like this, come like this, do like this. Now it is tetrahedral in shape. I was telling you how do we make a alkane to be a tetrahedral in shape. JAMB will now ask you, what organic compound has a tetrahedral, or that is tetrahedral in shape? Know that it is this topic that we are talking about, subtopic that we are discussing, alkane. How? This is methane. You can see 1, 2, 3, 4. 1, 2, 3, 4. What tetra? The word tetra means 4. Tetrahedral means it has a four-sided what? Four-sided angle, four-sided shape. That's why we classify them. The same thing. If you still draw that of a thing, this is this, this is this, this is this, this is this, this. You will still see that it is tetrahedral. Let's join it like this, like this, like this, like this, like this, like this, like this. Sorry for my drawing like this, like this, like this. See, like this. 1, 2, 3, 4. If you still do this one too, join it like this, like this, like this, like this. 1, 2, 3, 4. Are you? So we call it tetrahedral in shape. Please know that Alkane is this what? Tetrahedral in shape. Another key point here, that is just the short definition of what these are the little questions that JAMB might ask under the definition of alkane. Now let me join everything together. Now let's quickly, with what I said now, before we go to another something under this ANE. Well, now if anyone asks you, or if they ask you based on this summary, what is alkane? Alkane, now I'll say what? Alkane can be defined as an organic compound. You know, it is an organic compound because we deal with only carbon and hydrogen. It is an organic compound that is what? A saturated hydrocarbon with a bond angle of 109.5. Are we together? It is a single bonded molecule. It has a general formula CnH2n plus 2. It is also tetrahedral in shape. These are the summary of what we discussed. Are we together? Please, have you put in that? These are what they might ask under the definition of alkane. Now let's quickly see. Let's quickly go to the chemical properties of alkane. The chemical properties of alkane that they might ask you for this is that it undergo combustion reaction. It undergoes what? They can ask you, what undergoes combustion reaction? Know that they might list something that the similarity between alkane, alkenes, alkyne are what reaction? The similarity between alkenes and alkyne are what reaction? Is it combustion reaction? Is it substitutional reaction? Is it additional reaction? Or what? Now know that the similarity that guide this and this is that they are what? They all these three undergo combustion reaction. They undergo combustion reaction. It's very simple. What do we mean by combustion reaction? A combustion reaction is when an organic compound, the organic compound might be alkane, might be alkenes or alkyne. When it might even be alkanol, it also do that. When they react with oxygen gas, the reaction that exists between an organic compound and oxygen gas to form carbon dioxide and water is what we know as what? Combustion reaction. Organic compound reacting with oxygen to form carbon dioxide and water is what we call combustion reaction. So these three organic compounds undergo combustion reaction. We are still on chemical properties of what? Alkane. That what are the likely things that alkane can react with to get another thing. That's what we call chemical properties. Now if alkane reacts with this, what is it going to give us as the product side? Now let me bring more. So if they ask you now, the jamb will now ask you, alkane, alkenes, alkyne ask what similarities? They ask what similarities? A. Substitutional reaction. B. Combustion reaction. C. Additional reaction. Know that the only similarity between these three is what? A combustion reaction. Please, have you put in that? Note that. It's a jamb question they go ask. Now let's go to this. We want to pick alkane. Let me use, what is the first family of alkane? Methane, which is CH4. When I mean combustion, this is combustion reaction. CO4, CH4 plus O2. Now the reaction between methane, this is a methane, this is oxygen what? Oxygen what? Gas. Oxygen gas. Because of the two. And to give us carbon dioxide and what? H2O, water. This type of reaction, we call it what? A combustion reaction. They might ask you, the jamb might still ask you, this type of reaction, they will bring this type of reaction. They will not say, it is what reaction. Now, the jamb, another question on this. You know, we are under chemical properties of ANE, alkane. Now, the first chemical properties of alkane, it undergo combustion reaction. This is an organic compound, carbon to hydrogen, organic compound, from family of what? ANE. When it's reacting with oxygen gas, these are the two products. And jamb, let me bring three questions that jamb might ask you on these chemical properties. They will ask you, what is the reaction that only gives carbon dioxide and water? What is the reaction that only gives what? Carbon dioxide and water. Don't even think about it. It is combustion reaction. What is the reaction that only gives what? Carbon dioxide and water. It is what? Combustion reaction. How? What is this? The second question. What is the similarity between this and this? It is also combustion reaction. Making how many questions? 2 questions. Another thing, they can ask you, this one, this is a combustion reaction. What particular organic compound undergo combustion reaction? Alkane undergoes that. Alkenes undergoes that. Alkyne undergoes that. Are we together? Now note, let's balance this up. How many carbon is there? 1. How many carbon? 1. How many hydrogen here? It is 2. You can put 2 here. This is 4. But it has affected this one. 2 oxygen here now, plus 2 here, making 4. Then you put 2 here. You know how we balance now. That is chemical balancing. So now 4 oxygen here. This has been 2 here, making 4. 1 carbon, 1 carbon. 4 hydrogen, 4 hydrogen. This is the one chemical properties of alkane. Am I communicating? These are the things. They can bring another one so that what they can still ask you, what is the mole ratio? Mole ratio of oxygen gas in this combustion reaction. Damp by doing that. The mole ratio or mole coefficient, let me put it, mole coefficient of oxygen gas in this particular combustion reaction, just check this front, it is 2. If they say the mole ratio of or mole coefficient of carbon dioxide, this is carbon dioxide, what is the mole coefficient? Just be checking this front. What did you see at this front? 1. What did you see at this front? If it is for oxygen, 2. What for methane? 1. What for the water? 2. These are all we call mole coefficient. These are the likely questions they can ask on that. This is that. And they can still bring another C2H6 plus O2. It's also give us, this is ethane, number 2 of this family, A and E. When it reacts with this, I told you, they only give how many products? 2 products. Know that they can ask you. Combustion reaction give how many products? Carbon dioxide, jamb will not bring it. Carbon dioxide and what? Don't think about that. And water. What do we have for this product side? Carbon dioxide, and we also have water. The only reaction that gives only carbon dioxide and water is combustion reaction. Please, are we getting it? Now, please, the assignment on this, ethane, this is ethane. When it is reacting with oxygen gas, you know that it will still give us the same product because it's a combustion reaction, carbon dioxide and water. Please try and balance that. That is under that. The second aspect of this that I want you to still take note, it also undergo substitutional reaction. This ANE, alkane, undergo what? Substitutional reaction. They ask you, what is the difference between these three? You know, I've told you the similarity. The similarity, all of these three undergo combustion reaction. But the difference is that only one of them undergoes what? Substitutional reaction, which is this ANE that we are treating. Are we together? Now, it undergoes substitutional reaction. What makes it to undergo substitutional reaction? And what is the essence of this substitutional reaction? What is it going to give us? What do we really want to achieve in this substitutional reaction? Please try and note that. Are we really on the same page? Now, I will still bring what are the likely or are the secret questions that jamb we ask under the substitutional reaction. The same way we do under combustion. The first question that jamb we ask, that might likely ask you, please let me quote and unquote, that they might likely ask you is that, because I've seen the past question and I've seen so many things, it's because of the time frame I will bring in the reference. But believe me, if you check your past question series, you'll be seeing all what I'm saying there. So now, in this is the second chemical properties of ANE that we're discussing. It undergoes substitutional reaction. When they say when you are playing, if you are fans of football and you are playing football, you know they will say let's substitute one footballer for another one. So the same thing applicable to this. The substitutional reaction, this is the reaction that involves the reduction of hydrogen from an organic compound. The organic compound mainly alkane. When we are removing hydrogen from that this alkane and we are replacing it with halogen family. What are the halogen family? The halogen family are chlorine, fluorine, bromine, iodine, astatine, and many more. They are the group 7 what element. What end them? INE. What end this one to? IND. What end this one? IN. Chlorine, fluorine, ring. We classify them into what? Halogen family. They are the group 7 family. When we get to periodic table, we are still going to discuss that. I will let you know how do they fall on group 7 what? Group 7 element. Why do they call them group 7? But just know that we are not really going to that. Now, when we are now removing hydrogen, let me pick one. You know we have what? What do I pick CH4, which is methane. And I'm now removing this hydrogen. We are not dealing with chlorine. We are only removing, you'll be removing hydrogen. Then you are replacing it with one of this family. The out of you replacing it with chlorine, with fluorine, with bromine, in chemistry class, as far as organic chemistry is concerned, is what we know as substitutional what? Reaction. Are we together? It's very simple. Don't cram. Just try and understand what we are actually saying. So just be removing hydrogen. Be replacing it with one of these things. We call it what? Substitute. What do the jamb want to achieve there? What are the likely questions that they might draw up there? I've explained what you will say when someone asks you substitutionary reaction is the deduction of hydrogen from the family of alkane and the replacement of it with this family is what we know as what substitutionary reaction. Let me now be reviewing question on that. Now the first question I will review that they might bring. What amidst this option listed, what is the organic compound that only undergoes substitutionary reaction? Don't think about alkenes. Don't even go to alkyne. What should come to your mind is what? It is alkane. If you have this 3 option, what should come to your mind is A-N-E. The one that ends with what? A suffix of what? A-N-E. That should come to your mind. Substitutionary reaction. That is the difference between the 3. But the similarity is the combustion reaction. Let's quickly do that. Let's quickly, and that is first question that Jam might ask you. The second question, that what is the only reaction that gives an anesthetic agent? What is the only, that is the second question that Jam might ask you. What is the only reaction that gives a what? That gives an anesthetic agent. What do we mean by anesthetic agent? I mean that serve as a pain reliever. They use it at hospital when they want to do CS. They want to operate. So what is the compound that they use in doing? They will not bring. They will not bring option. Is it substitutionary reaction? Is it combustion reaction? Is it saponification reaction? Is it esterification reaction? Don't even go to any one of them. Know that it is substitutionary reaction. There is the second question. The third question, what organic compound gives us an anesthetic or that result to the product of the formation of anesthetic agent? What is the organic compound that results in the formation or in the product of anesthetic agent? When I mean anesthetic agent, I mean this is what I mean. Trimethylchloride. Trimethylchloride. I will tell you what we call it chloroform. Chloroform. Are we? And it is also an anesthetic agent. Anesthetic agent. The word do we mean by that? It serves as pain reliever. I've told you earlier. Then what is the reaction that leads to the formation of anesthetic agent? Don't even go to anyone. Additional reaction doesn't lead to anesthetic agent. Combustion reaction doesn't lead to anesthetic agent. I've explained that. It only gives us 2 products: carbon dioxide and water. The only reaction that leads to anesthetic production is substitutionary reaction, and it is mainly for alkane. It is mainly for what? Alkane. A-L-K-A-N-E. Let's quickly do that. What would they use this for? They use it as what? In subjecting or subduing pains. Serve as pain reliever. When they want to operate, they will inject it to this patient, and he or she will not feel any pain until they finish what they want to do. That is the essence of this substitutionary. I'm telling you the uses of this substitutionary reaction. Jamb might ask you, what is the reaction that gives or that leads to the production of pain? Now they can ask you, what is the reaction that leads to the formation of pain reliever? They will not list the option. Is it substitutionary reaction? Is it combustion reaction? Is it additional reaction? Don't think of anything. Only reaction that leads to what? Formation of pain reliever, which is this thing, trimethylchloride. It is what? It is a substitutionary reaction. Don't even go. Don't think about the esterification reaction. That's another thing entirely. When we get to that, I will let you to know. So let's be focused on these. These are the questions that they might likely ask you. Now let's do the last question that they will ask you on this part, under this chemical property, is that they can ask you, what is the catalyst used in production of this reaction? What is the catalyst? When we say catalyst, what speed up the rate of how this reaction applied? What makes this reaction to fastly happen? That's what we call catalyst. Don't think of anything. It is ultraviolet radiation. Ultraviolet what? Radiation. Ultraviolet radiation. Or sunlight, anyone. But this is the common catalyst that they use. Sunlight is this one is also formed from, is also as a result of sunlight. Ultraviolet light. We call it UV. That is the short form, UV. abbreviation, ultraviolet radiation. So they can ask you, what catalyst do they use in substitutional reaction? They will not bring it. A, nickel. B, concentrated tetrasulfuric acid. C, they might bring another one. Then D, they will bring ultraviolet radiation. As far as this ANEC is concerned, it is ultraviolet what? Radiation for substitutional reaction. Are we in for that? Now, these are the questions that they can ask under this second chemical properties of ANE. Now, which we have, what do we have? We have CH4 plus Cl2. I told you that the removal of hydrogen, the addition of what? Chlorine. They can use bromine, they can use iodine. But know that when you are using bromine, it will also be Br2. When you are using iodine, it will also be HT. When you are using now these, when you see this, they are all gas: bromine gas, iodine gas, chlorine gas, chlorine gas. When they are replacing it and they are removing hydrogen, it's what we call substitutional reactions. Are we together? Now, what follows is that you'll be removing. Let's be removing. What are we removing here? We'll be removing what? Hydrogen. Let's be removing hydrogen. That is the essence of substitutional. Remove hydrogen here. Then remove chlorine here. You know it is 2 chlorine. Add the remaining chlorine, add it to this one. Remain how many hydrogen here? 3. So you just leave that C. CH3. Then the hydrogen and chlorine that you put in. Chlorine. Then this one, H, and this one, Cl, plus HCl. This is hydrochloric what? Acid. And this is what? Methyl chloride. The same thing. This still bring this product. Look down now. Now you put UV here. UV, ultraviolet radiation. You put UV here, ultraviolet radiation. This is the first product. You are having 4 processes to do. The second one, bring this product, bring it to this side, which is a methyl chloride, CH3Cl. Plus, still add another new fresh chlorine gas. You know me, I'm only using chlorine. You can use bromine gas, you can use iodine. So, you still remove 1 hydrogen here, remove 1 chlorine here, making what now? HCl. Put it to this side, HCl. Is everything balanced? The next thing, this is, we are left with how many hydrogen here? 2 hydrogen. Then what is chlorine that is here? 1. Couple up with 1 chlorine that is left here. Hope you are now, you get what I'm saying. Remove 1 chlorine here. After we remove 1, that 1 chlorine, add this to this chlorine, making 2. Then this has been reduced to 2. It will now be CH2, Cl2. This is what now? This is dichloro methane. Are we together? So when we get to that, I will let you to know how is that dichloro methane. Just get that. Now what follows? Still bring this one. And in the presence of what catalyst? Ultraviolet. I've explained that. Still bring that CH2 Cl2 plus what? Cl2. On the presence of UV again, ultraviolet radiation. Now remove 1 hydrogen from here until you remove all the old hydrogen. That's what we mean by substitutional reaction. You remove 1 chlorine here. Then everything becomes HCl. Then what are we left? This remain how many hydrogen? 1, which is CH. Then this is how many chlorine? 2. With the 1 that left here after we remove 1, making 3. CH3. This is what I call trimethyl chloride. Trimethane, which we call the chloroform. Trimethane, which we call the what? Chloroform. That's what I mean by the anesthetic agent. This is the trimethane. Chloroform. Trimethane. Now, this one, bring it back. CH3 plus Cl2 in the presence of what again? UV. Remove that hydrogen. 1. What of this one? Chlorine. Is there any hydrogen left here? No. Hydrogen, and then this is where you end your reaction. We are left with what? Carbon. Then how many chlorine there is here? Chlorine, it is 3 here. This plus 1 chlorine here, making what? Making 4. Plus 1 chlorine here, making what? 4. It will now be CCl4 plus what? HCl. This is what now? Tetra. Now when we remove that, we are left with what? I've removed 1 hydrogen here, chlorine here, making what? We remove what here? There is not any hydrogen here again. So it's because of there is no space here. C, how many chlorine there is here? 3. We have removed one here, remain one here, add it to that. CCl4 plus this one and this one, hydrochloric acid. This is what now? This is chloro methane. Is there any hydrogen here again? No. In the presence of what catalyst? Ultraviolet. Or this is what we call a substitutional what? Reaction under chemical properties of alkane. 1, 2, 3, 4, then 5. Are we together? These are all we know as what? A substitutional reaction. The act of removing hydrogen and splitting in what? Chlorine or bromine or iodine. Or know that if you are using bromine, chlorine, iodine, you only use, what do I use throughout? Chlorine. If you want to use bromine throughout. Are we together? So that is that under that. Thanks for the listening and thanks for hearing. Your assignment for this is that you to please do practice that. Do for CH for methane plus bromine gas and use UV as the ultraviolet radiation for this substitutional reaction. And you might end up this. It will now be tetrabromometane. That is the answer that you get at the end of the result. So if you find this video very helpful, don't forget to like, share, and also what? Subscribe to the needies. Please save those people that they are about preparing for jamb. Save them and try send it to your friend, your family that they are preparing for this, and let them gain. It might be or whatever we discussed today might be what we add to the mark that they want to score, and might even be the suburb to the entering of how, irrespective of the university you want to enter, and what the subject of the interest, I mean your course interest you want to pick. It might be one of what we do here today might help you to score a good grade, 300, 290, and many more. And note that my only advice for you is that always do definement. Definement, map reading, and it will truly help you a lot. And know that you have to be prayerful. Prayerful, preparation, prevent poor performance. These are the 5 P. You have to be prayerful. Pray to Almighty Allah, and if you are Christian, pray to your Christian, pray as a Christian something. If you are one of, just pray. Pray and you have to prepare. When you are praying and you are not preparing, you are really doing yourself. Prepare. It will prevent you from having a lower grade. I wish you best of luck. I still remain my humble self, Akorede Oluwayinka, assigned at SUP Academic Online Class. Please watch more for the physics, chemistry, mathematics, and many more of our video regarding science subject. Based on we are doing for SSC, we are still doing for A-level students, 100 level students, 200. As far as science subject is concerned. Barakallahu fikum.